Good morning, everyone. So today we're going to talk about acids and bases and the pH scale. So I'm just going to read through the note. I've provided you the note. I'll go over the worksheet, which is just answering questions about the note, and then you're going to submit that in. So all fizzy carbonated drinks contain carbonic acid. Fruit-flavored drinks often contain citric acid. Cola drinks contain phosphoric acid. These acids react chemically with your teeth to weaken them. Bacteria can also weaken your teeth as they secrete acid as a waste product when they live in your mouth. Sodium fluoride chemically reacts to the calcium in your teeth to make a hard coating that helps prevent tooth decay. So what this is showing is that we have acids and we deal with acids in everyday life. Okay, when you have a can of Coke, there's a variety of acids. If you have a bit of lemon, there's acid in that as well. And it does affect your teeth. And so that's why it's important to brush your teeth, or you start seeing them become weak and you start developing cavities. Some common examples of foods are lemons, grapefruits, vinegar, apple, and yogurt. Now, the important thing here is that acids have a sour taste. Okay, so it's important to maybe star that. Okay, and here are my examples here. So there's acid in pickling juice. Okay, so that's where we put vinegar. And a lot of our citrusy fruits have acid in them as well. Some acids can be quite strong and therefore dangerous. They can cause severe burns to the skin. Many metals can experience corrosion by acids. Now, if you remember from yesterday, corrosion refers to the chemical reaction which one substance eats away or breaks down the surface of another substance. So those are kind of the acids we deal with every day. So examples of bases. Common examples of foods that contain bases include eggplant, unsweetened chocolate, bitter melon, and tonic water. Okay, these things taste bitter. So bases taste bitter. Like acids, bases can be quite strong and corrosive. They are commonly used in oven cleaning and drain clearing products. They don't corrode metals, however, and that's why we use them to clean metals. So below is a chart that compares acids and bases. Okay, so acids taste sour, bases taste bitter. Acids don't have a clear texture when you touch them, but bases feel slippery. Okay, kind of like soap, that slippery feeling. Acids can conduct electricity when dissolved in water, and so can bases. Acids can corrode living and once living tissue as well as metals, and so can bases if they are strong enough. Chemical reactions with metals. Acids are very reactive with metals, where bases are not. Chemical reaction with litmus paper. Now, litmus paper is an indicator. It's like a piece of paper, and you dunk it in, and it turns color depending if it's an acid or a base. So if you dunk this litmus paper in an acid, the blue litmus paper turns red. Okay, if you dunk it into a base, okay, so if you're considering it being a base, you take a red litmus paper and it will turn blue. So these are indicators. Chemical reactions with each other. Acids may lose many of their properties when they react with bases, and so does bases with acids. So what we can do is, if we have something that's really acidic, we can add a base to it, and we can neutralize the reaction. And so what happens, it creates water, so it becomes neutral. And we're going to talk about pH scales. So acid. So again, they react with metals and carbonates. They conduct electricity. Okay, they turn blue litmus paper red and neutralize bases. So they taste sour, but you should never taste an acid in the lab. Anything that you're tasting that's an acid is usually something that we're allowed to eat. There's a small amount of it. But if you have like a beaker of hydrochloric acid, I wouldn't suggest drinking it or touching it. Acids are very useful in the food industry as they act as a food preservative. Okay, so like pickles and barbecue sauce and ketchup, they have long shelf lives because they contain a lot of vinegar, which is an acid. And that acid is called acetic acid. Chemical formulas of acids. So all acids release at least one hydrogen ion, okay, when they dissolve in water. And this is symbolized by AQ. So that means aqueous, okay, which means it's a liquid. So it's dissolved in water. For example, hydrochloric acid forms one hydrogen ion and one chloride ion. So this is when you look at this right here, you can see that this is an acid because it has a hydrogen here attached to another element. In this case, it's chlorine. So hydrogen chloride will undergo a decomposition reaction, okay, and you will produce hydrogen ions and chlorine. Okay, so this right here, this hydrogen ion lets you know that this was an acid. It is this free hydrogen ion that makes acids what they are. Notice acids have an H in front of their formula. Now on your periodic table, I've given you a table, okay, full of acids. I'm not going to ask you to name them, but we're just going to go over that very quickly. So names of acids, there's two common groups of acids. One group is called binary acids because these compounds contain only two elements. Things like hydrochloric acid, hydrobromic acid, okay? Most acids that you encounter are either in a group called oxyacids. They have more than two different elements in the formula. Note that they still have the hydrogen atoms in front of the formula. So that tells you that it is an acid. So if you see an H in front of another element, okay, that is considered an acid. And the way they name it, they name the H as hydro, and then you name the second element, and you put it together with IC at the end, and then you add acid. So that's how you name an acid. Bases are similar. They're not similar. Bases are substances that conduct electricity and change the color of an acid-base indicator. So they feel slippery and they taste bitter. So again, don't taste them, okay? Just like acids, they dissolve in water. So this time, instead of producing a hydrogen ion, they produce a hydroxide ion. Okay, so remember this is a polyatomic ion. So here we have sodium hydroxide, NaOH. So if you see this hydroxide ion, okay, that tells you that it is a base. So when it undergoes a decomposition reaction, you see the sodium here and you see the hydroxide ion. So that tells you that it is a base. Some acid-base indicators, certain substances are designed to change color depending if something is an acid or base, and we call them acid-base indicators. So for example, those litmus paper, but something that you're probably more comfortable with is called a pH indicator, and we're going to be looking at those. Names and formulas of bases. Okay, so I have some on the side. Just remember when you see the hydroxide there, okay, that tells you it's a base. Okay, so when you're seeing a formula like potassium hydroxide here, you're seeing the OH group, and that tells you that they're bases. Now, some have end with an N, so they might have a nitrogen atom in their formula. So for example, ammonia is a very strong base, methylamine is a base, and so is pyridine. But these OH groups is what I would only ask you to identify as a base. Okay, so for example, potassium hydroxide, we use that to make soap and some drain cleaners and bleaching. Sodium hydroxide, which is lye. Okay, so making soap, paper textiles, and some drain cleaners, and etc. Calcium hydroxide is something that is in plaster, cement, and mortar. Something to always remember. I know when lots of people make cement and stuff, they don't wear gloves and they got their hands in it. Over time, it will start to corrode your skin, okay, because it's so strong. That's why you see a lot of people who make sidewalks or bench bases and stuff like that. They wear gloves because you don't want that on your hands. Okay,